Hey everyone, and welcome to this in-depth exam prep explainer covering Objective 13.3 for the Nutanix NCP-MCI 7.5 certification. If you're an infrastructure admin gearing up for this exam, you already know that data protection is an absolute cornerstone of the Nutanix architecture. Well, today, we're getting highly specific. We're zeroing in on exactly how Prism Element handles RPO schedules across asynchronous, NearSync, and synchronous replication. We're going to unpack the underlying architecture, walk through some real-world examples, and, most importantly, highlight those strict limitations and edge cases that exam writers absolutely love to test you on. So, let's dive in. Here is our blueprint for today. We'll quickly cover why RPO schedules matter, move into an async and NearSync walkthrough, tackle synchronous replication, look at real-world RPO examples, dig into those tricky exam traps and edge cases, and wrap up with the key facts you need to memorize. All right, kicking things off with Section 1, Why RPO Schedules Matter. To set the stage, we need to quickly anchor ourselves on DR and RPO. We all know DR, or disaster recovery, is your overarching strategy for bringing your IT infrastructure back online after a crisis. But RPO, your recovery point objective, that is the critical metric here. It dictates exactly how frequently your system generates restore points. In Prism Element, your RPO specification is the literal engine driving the underlying replication. The second you set a policy, boom, that first restore point is created immediately. After that, subsequent points are generated strictly according to the RPO you defined. Ultimately, this dictates your maximum potential data loss. So if your RPO is set to 1 hour, you are accepting that you might lose up to 1 hour of data if a disaster strikes. Simple as that. Moving right along to Section 2, our async and NearSync walkthrough. Now, there is a very strict boundary you must memorize for your NCP-MCI exam. Nutanix categorically splits these two schedules based purely on time. Async DR, or async, covers schedules with an RPO of 60 minutes or greater. When you're operating in this tier, the system relies on traditional incremental snapshots. You're configuring these in terms of hours, days, weeks, or even months. On the flip side, NearSync DR handles the highly aggressive RPO window of strictly between 1 and 15 minutes. Now, technically speaking, NearSync is still an asynchronous process. But because the frequency is so incredibly high, it requires a completely different set of architectural rules to function without totally overwhelming your cluster. To understand how NearSync actually achieves such tight intervals, we need to define two things: LWS and VG. LWS stands for lightweight snapshots. This is a proprietary Nutanix technology that generates continuous snapshots strictly at the metadata level, rather than doing heavy, resource-intensive block-level copies. VG stands for volume group, which is essentially the block storage presented to your virtual machines or physical servers. These two definitions are vital because they dictate the strict requirements for NearSync to even operate in the first place. So, let's look at the underlying architecture. Why can NearSync run every single minute without crippling your performance? It all comes down to those lightweight snapshots. When you configure a NearSync schedule, Prism Element automatically allocates an LWS store. But here is a massive fact you need for the exam. This LWS store is allocated strictly on the SSD, or solid-state drive tier. It never, ever goes to spinning disks. And to protect your cluster's performance, Nutanix enforces some hard limits. The maximum LWS store allocation for each node is strictly capped at 360 gigabytes. Furthermore, if you're running a hybrid system, meaning a mix of SSDs and HDDs, that allocation is limited to exactly 7% of the SSD capacity on that node. If your system doesn't meet these exact requirements, NearSync simply won't function. Commit those numbers to memory. Okay, Section 3, let's tackle synchronous replication. Synchronous replication, which you'll often hear referred to as metro availability in the AHV world, provides a literal 0-second RPO. There is no time interval to configure here. The system instantly replicates all writes on the protected entities directly to the recovery cluster. In fact, a write is not even acknowledged back to the guest virtual machine until it has been successfully written to both the primary and the secondary site. This is reserved for your absolute mission-critical applications where zero data loss is the only acceptable metric. For the exam, there are a few very specific operational details you need to know about synchronous replication. First, it supports protection domain-based DR between clusters running VMware ESXi and Microsoft Hyper-V hypervisors. Second, these protection domains operate in strict active and standby states right across your sites. And third, pay attention because this is a classic exam gotcha. When a volume group is synchronously replicated, the dormant volume group is not available for consumption on the recovery cluster. Yes, it's there, and yes, it's receiving writes instantly, but your applications on the standby site absolutely cannot mount or consume it until a failover event occurs and that domain is officially promoted to active. Let's put this into practice with Section 4, Real-World RPO Examples. Our first example is transitioning a VM into a NearSync schedule. It is vital to know that a VM doesn't just jump to a 1-minute NearSync interval the exact moment you click Save. The system has to protect itself first. When you configure NearSync on a protection domain, it initially remains on a standard hourly async schedule. Prism Element generates the first snapshot and begins replicating that heavy initial seeding data across the wire. While that's happening, it concurrently starts generating those metadata-level LWS snapshots in the background. Only once the system determines that the initial seeding snapshots have successfully replicated across does the cluster automatically transition into your requested NearSync schedule. And that transition? It depends entirely on your available bandwidth and your data change rate. Now, let's talk about retention policies, because this is fascinating. Imagine you configure NearSync replication with a 1-minute RPO, and you tell the system you want to retain those snapshots for 5 days. Think about that for a second. If the system literally kept every single 1-minute snapshot for 5 straight days, you'd be staring at over 7,000 snapshots for a single VM. That would absolutely destroy your storage capacity. Prism Element elegantly solves the storage nightmare by rolling them up. When you apply that 1-minute RPO for a 5-day duration, here's exactly what the system does. It creates a snapshot every minute, for sure, but it only retains the specific, granular 1-minute snapshots for 15 minutes. After that, it rolls them up. It creates a snapshot every hour and retains those hourly snapshots for 6 hours. Finally, it creates one daily snapshot and retains that for your requested 5 days. This is a brilliant system because it gives you hyper-granular recovery for the immediate past while providing sensible, space-saving recovery points as you look further back in time. All right, grab your highlighters for Section 5, Exam Traps and Edge Cases. There is a strict limitation pulled directly from the Prism Element Data Protection Guide. You cannot have a schedule with an interval between 16 and 59 minutes. This is the forbidden gap. Remember our boundaries from earlier? NearSync is 1 to 15 minutes. Async is 60 minutes or greater. So if you get a scenario question on the exam asking you to configure a 30-minute or 45-minute RPO natively in Prism Element for a standard protection domain, the answer is that it is an invalid configuration. You simply cannot do it. Another massive trap is the concept of hidden snapshots. Even when you set a strict schedule, Prism Element takes some liberties behind the scenes to guarantee data integrity and facilitate those roll-ups we just talked about. For asynchronous schedules, the system secretly generates an extra snapshot every 6 hours, regardless of what you set. For NearSync, it generates an extra snapshot every 1 hour. Now, why does this matter for the exam? Well, if you have a protection domain that has both an async schedule and a NearSync schedule applied to it, you effectively have 2 different 1-hour schedules running concurrently. The system strictly requires that these schedules align to reduce the number of full hourly snapshots and prevent your storage from bloating. This brings up 2 more crucial operational hazards. First, if you have multiple replication schedules, it is highly recommended that you stagger their start times. If too many schedules share the exact same start time, your replications can fall behind simply due to bandwidth and processing bottlenecks. Second, if you delete a schedule, the snapshots that were taken while that schedule was active do not automatically get deleted. They will just sit there consuming space until they age out of their retention policy naturally or until you manually intervene. Never assume that deleting a schedule cleans up your storage footprint. Almost done. Let's hit Section 6, Key Facts to Memorize. Lock this summary table into your brain for the exam. The lines are drawn strictly in the sand here. Synchronous replication is a flat 0 seconds. NearSync operates exclusively between 1 and 15 minutes, utilizing those metadata-level lightweight snapshots on the SSD tier. You have a forbidden gap where no native schedules can be configured between 16 and 59 minutes. And finally, asynchronous replication handles everything at 60 minutes or greater using your standard incremental snapshots. To wrap up our explainer today, let's test your deep understanding of the platform's roll-up rules with a real-world scenario. If you configure a 1-minute NearSync schedule, exactly how many of those granular 1-minute RPO snapshots will actually be visible and available for a restore operation in the Prism Element UI at any given time? Think carefully about the retention roll-up rule we covered earlier. It's these kinds of specific architectural boundaries that separate a standard admin from a certified Nutanix engineer. Do you know the answer? Review your notes, trust your platform knowledge, and best of luck as you prep for your exam.